So in this video, we're going to continue the problems on a chain drive. So we're going to select a problem now. Select a chain drive to actuate a compressor from 10 kW electric motor at 970 RPM. The compressor RPM being 350. The minimum center distance should be approximately 560 mm. The chain tension may be adjusted by shifting the motor on the rails. The compressor is to work for 10 hours per day. So for the problem, the given data is the power is given 10 kilowatt and N1 is 970 RPM, so N2 is 350 RPM. So approximate center distance is given as 560 mm and working of 10 hours per day. So first step will be finding the pitch of the chain. So P less than or equal to 25 into 900 by N1 all to the power of 2 by 3. The equation number 21.106C. So I'm going to substitute N1 value as 970. So I'm going to substitute, I'm going to get value as 23.78 mm. So from the table 21.64, the nearest value for that will be 25.4 mm. So I'm going to take that. So from the table, again I can select the chain number as 208B. So braking load FU is equals to 17.9 kilonewtons or 17,900 newtons. The measuring load W will be 127.5 newtons. The next step will be number of teeth on the sprocket, that is N1 by N2. That will be equals to 970 by 350. So I'm going to get as 2.77. So if you go for a table 21.60 for N1 by N2, that is a ratio of 2.77. The number of teeth on a smaller sprocket should be equal to 26. That is Z1 is equals to 26 teeth. Now N1 by N2 is equals to Z2 by Z1. We know that. So I have to find out Z2. So I'm going to get Z2 as 72 teeth. So number of teeth on the larger sprocket will be 72. The third step will be pitch diameter. So the D will be equals to P by sine 180 by Z, equation number 21.126. So the pitch diameter of the smaller sprocket, so D1 is equals to P by sine 180 by Z1. So I'm going to get as 210.724 mm. Similarly, when I go for the larger, so D2 will be equals to P by sine 180 by Z2. So Z2 I'm going to substitute as 72. So I'm going to get as 582.31. The fourth step will be based on the velocity. So velocity is equals to P Z1 N1 divided by 60,000. So P pitch which is selected is 25.4. Z1 is 26 and N1 will be 970 by 60,000. I'm going to get as 10.6765 meter per second. So the required pull, that is power N is equals to F theta into V divided by 1000 KL into KS. So KS I'm going to take 1 for 10 hours duty per day. And from the table 14.4 or table 14.7, so for a compressor KL will be equals to 1.75. So when you're going to substitute all the values, I'm going to get the required full F theta is equals to 1639.12 Newton. So now I have to go for the allowable pull, that is the next step. So allowable pull FA is equals to FU by N0. So N0 is not known, so you have to go for a table number 21.75. For N1 970 RPM and P is 25.4. So I'm going to select N0 as 12.9. So FA is equals to 17,900 divided by 12.9. I'm going to get allowable pull as 1387.6 Newton. So number of strands. To find the number of strands, I have to go for I, that is F theta by FA. So required pull by the allowable pull, that is 1639.12 divided by 1387.6. So I'm going to get as 1.18. So I'm going to assume number of strands as 2. So check for the actual factor of safety means, to check the actual factor of safety, I'll go for formula NA is equals to FU divided by F theta, FW and FS, that into I. So FW is nothing but the FCS I want to assume over here, that is F theta is equals to 1000 into power divided by velocity. I'm going to get as 936.64 Newton. FCS, that is nothing but WV square by G. So I'm going to get W is already taken, velocity we find out, G is 9.81. So I'm going to get as 1481.5 Newton. So for finding Fs, so I have to go for table number 21.58. For a horizontal drive, the KSG will be equals to 6. So I'm going to substitute 6 over here and W is already known. And C I have to go for 560 by 1000, that is I'm going to take the value. So I'm going to get as 428.4 Newton. That is the C is given as 560 mm. So I'm going to convert into the meters. I'm going to get as 428.4 Newton. Therefore NA will be equals to 70,900 divided by the values multiplied by number of stand, that is 2. So I'm going to get as 12.576. So Since Na is equals to N0, the selection of the chain is the safer one. The next will be the length of the chain in pitches. So I'll go for the formula. LP is equals to 2 Cp cos alpha plus Z2 plus Z1 by 2 plus alpha Z2 minus Z1 by 180. So I'm going to find out alpha value, that is sine inverse of D2 minus D1 by 2C. So I'm going to substitute D2 and D1 values, and I'm going to substitute the center distance also. I'm going to get as 19.376 degrees. So I'm going to substitute all the values in this above equation. I'm going to get length of chain, that is LP, in terms of pitch as 96 pitches. So the length of the chain will be L is equals to P into LP, that is L is equals to 25.4 into 96. I'm going to get as 2438.4 mm, that is, it is in terms of mm. So correct center distance, so LP is equals to 2 C by P cos alpha plus Z2 plus Z1 by 2 alpha Z2 minus Z1 by 180. So I'm going to substitute all the values except C. So I'm going to get C as 566 mm. The actual what they specified is 560. So the corrected center distance I'm going to get as 566 mm. So that finishes the problem. So let us consider the next problem. Select a chain drive to actuate a compressor from 15 kilowatt electric motor at 600 rpm. The compressor rpm being 120. So the given values will be, power is given as 15 kilowatt, N1 they given as 600 rpm, N2 they given as 120 rpm. So I'm going to go for the first step, the pitch of the chain. So I'm going to use the formula P less than or equal to 25 multiplied by 900 by N1 all to the power of 2 by 3. So I'm going to substitute, I'm going to get that value as 32.75 mm. So once you got this 32.75 mm, I'll go for the table 21.64. The nearest standard value of pitch P is equals to 31.70 mm. So select the chain number 210B. Breaking load Fu is equals to 22.3, that is 22,300 Newton. The measuring load W is equals to 196.1 Newton. The next step will be number of teeth on the sprocket, that is N1 by N2 is equals to 600 by 120, that will be equals to 5. So from the table 21.60 for I is equals to 5. The number of teeth on the smaller sprocket will be Z1 is equals to 21. So therefore N1 by N2 is equals to Z2 by Z1. So I want to get Z2 as 105 teeths. The third step will be pitch diameter. So D will be equals to P by sine 180 by Z. So I'm going to substitute Z1 and Z2 over here to get D1 and D2. So I'm going to get D1 as 212.69 mm and D2 as 1059.65 mm. The next step will be the velocity. So V is equals to P Z1 N1 divided by 60,000. So I'm going to substitute the pitch, that is 31.70 multiplied by 21 multiplied by 600 divided by 60,000. So I'm going to get 6.657 meter per second. So once you got the velocity, I'll go for the required pull. That is N is equals to F theta into V divided by 1000 KL and KS. Assuming 24 hours per day, so KS I'm going to assume as 1.2. So from the table 14.4 or 14.7. For a compressor, the KL will be equals to 1.75. So and I'm going to substitute all the values over here. I'm going to get required full F theta is equals to 4731.8612 Newton. So next I go for allowable pull. So from the table 21.75 for N1 is equals to 600 rpm, P is equals to 31.70 mm. So N0 will be 13.2. So FA will be equals to Fu by N0. So Fu you are taken as 22,300. So N0 will be 13.2. So I'm going to get as 1689.4 newtons. So number of strands. So I is equals to F theta by Fa. So I'm going to substitute the values. So I'm going to get as 2.8. So I'm going to take that one as I is equals to 3 strands. So check for the actual factor of safety. So I'll go for actual factor of safety. Na is equals to Fu by F theta FCS into Fs multiplied by I. So F theta 1000 into N by V. So I'm going to get as 2253.27 Newton. FCS WV square by G. So I'm going to get as 885.861 Newton. And Fs, that is KSG W into C. So for a horizontal drive, KSG will be equals to 6. And C is 30p to 50p. So I want to assume the C maximum and minimum. So I want to take that one as 1000 mm. So I want to find out both the values. So I want to assume as C is equals to 1000 mm. So Fs is equals to 6 into 196.1 multiplied by 1000. So 1000 it is in the mm. So I want to convert it into meters. So divided by 1000, I want to get it 1176.6 Newton. So substituting all these values in the previous equation, I'm going to get NA is equals to 15.5. So NA is greater than N naught. So the selection of the chain is safer. Then I'll go for the length. So length of the chain LP is equals to 2 CP cos alpha plus Z2 plus Z1 by 2 plus alpha Z2 minus Z1 by 180. So alpha I'm going to find out by using the formula sin inverse D2 minus D1 by 2C. So values are known. So I'm going to find out alpha is equals to 25.054. So substituting the alpha value, CP value, Z1, Z2 values in the above equation, I'm going to get LP as 132. So I'm going to take LP as 132 pitches. So length of the chain can be calculated by multiplying the pitch. So L is equals to P into LP. So that is 31.70 into 132. So I'm going to get as 4184.4 mm. So the last step will be correct center distance. So I'll go for the formula. LP is equals to 2 C by P cos alpha plus Z2 plus Z1 by 2 plus alpha Z2 minus Z1 by 180. So by substituting all other values, I can find out C as 1002.67 mm. The actual center distance what you have taken is 1000, but the correct center distance will be 1002. So that finishes the problems.